Hi everyone, we are still in section 3.6 and this is the fourth video, which is now examples number 3. But this one is going to talk about what do we do if we have common factors. And I'm going to do that in terms of two simpler ideas. And it would carry on into more complex ideas if you wanted to. And then I also have a more complex rational function that we're going to go through all the steps again and graph it or sketch a graph of it. All right, so first of all, I'm going to take this guy and I'm going to jump into it as if I didn't know much. And it's like, okay, we're supposed to sketch a polynomial over a polynomial. So our first step is to factor. The numerator already is factored, so I'm going to factor this denominator. I notice that there is an x in both. So I will factor that x out, and then this gives me 1 over x, or x times x minus 3. Now I want you to notice we do have an x minus 3 in both of those. Now algebraically we would normally cross those two things out and say that this is equal to 1 over x. However, we have to be a little bit careful because these two are not exactly the same. They are exactly the same except they don't have the same domain. This one here, the one we started with, we can substitute anything we want into it except for 0 and 3 because we get zeros in our denominator and we have problems. Here we still have that problem when x is equal to 0. So these two are identical except for one little thing. Okay, we talked about what 1 over x looks like. So this is 1 over x. Okay, so these two functions, this one, I'm going to put approximately or almost 1 over x because these are identical except this original one has one thing missing. It's this function with a hole in it. So if you took this point x equaling 3, our problem spot, and put a big old circle in that graph, this is what our graph would look like. So this function looks exactly like this, but with a hole where at x equals 3. I hope that makes sense. We're going to do one more just so you can kind of see it again. Again, first step is to factor it. The bottom is already factored. And we will notice that this is going to be, there's an x squared in there. And these are made to show these sorts of things. So these two, this is almost x squared. Okay, so I know what x squared looks like. It is my parabola. But my function is going to be that parabola with a hole in it. So there's going to be a hole at x equaling 2. The spot we took out, that x minus 2, that x equaling 2. So at 2, we would have been at 4. So there is a hole right there. Otherwise, our function looks the same as x squared. Now, if I were graphing this using a graphing calculator, you would not notice the hole. A lot of them do have this trace feature, but if you start tracing, you'll notice that it jumps right over that x equaling 2. You'll get x equals 2 and there'll be a gap for the y value. And it's because there's an actual hole there. But you can't see it because taking one point out of a graph is it's impossible to see. All right, so I've got another one. We're going to go back to some of those more difficult pieces. And here's my function. So this is a polynomial over polynomial. I've already factored it for us so that we can talk more about that multiplicity idea. Okay, so going to, it's already factored, so step 1 is done. We're going to be drawing our graph here. So I'll be doing lots of chicken scratching around here. Hopefully my chicken scratching all makes sense. My x-intercepts, so step 2 is to find our intercepts. Our x-intercepts come from the zeros of the, long pause so you guys can answer the question. Hopefully you guys are saying numerator. So our x-intercepts are going to be at 3. 1, 2, 3. So we're going to put a big dot there. -2 and 1. Okay, so our x-intercepts came from the zeros of the numerator. Our y-intercept is when we let x be 0. So letting x be 0, I'll have a -3 squared times 2 times -1 over -4 squared times -2 cubed. And if I'd been thinking, I would have chosen smaller numbers. So this would be 9 times 2 is 18, so -18 over 16 times 8. Let's see, kind of need that, because this would be a positive 16, and that would be a -8, and that's a -128, which I think reduces. It does to 9/64. The negative over negative is a positive. 9/64 is bigger than 1, so I'll just put a dot here. So there we go. I did have a high school instructor that always told me, when in doubt, just make the dot bigger. He did not allow us to get it too big, though, so just kind of warn you. So I made a nice big dot there, so I'm pretty sure I hit 9/64. There's our y-intercept. Our next piece was to find the vertical asymptotes. Vertical asymptotes were the zeros of the denominator. So we will have this guy in here. And we also, there's one at 2 and there's one at 4. 2, 3, 4. So we've got lots of stuff going on in this guy. There we go. All right, now we need to know if we have any horizontal asymptotes. And to tell if we have a horizontal asymptote, we need to know the degree of the numerator and the degree of the denominator. Okay, so thinking degree. So if I multiplied this all out, which I do not want to do, this would be an x squared, because I would FOIL it. This piece would be giving me an x cubed. This would then give me an x to the 4th, plus a bunch of other stuff. So this is a 4th degree. This would be a squared, and this would eventually give me a cubed, which would give me a 5. So 4th degree, 5th degree. The numerator is smaller than the denominator, which tells me y equals 0 is a horizontal asymptote. Okay. Now we're ready to graph our picture. And I'm going to do a few test points in here because I don't know where I am past here. All I know is I'm going to tail up eventually towards this value. So I'm going to test and look at what -1, 2, 3 is. So -3 in here. And I can use my calculator to give me a value. I'm just going to kind of wing it here. So I'm going to be off. So -3 minus 3, that's -6, so that's 36. Write these things down. Times a -1 times a -4. That's going to give me a big number. So 36 times 4. It's 144. All right, and I'm doing -3. So that's -3, so that's 49, because that's -7 squared. -3 minus 5, so it's -5 cubed is a -125. Whew, really big number. So 6125. And this is positive on top and negative on the bottom, so negative. but it's pretty close to, I don't know, somewhere in there. All right, so I know that I went from the 0 to this guy, and then eventually come back up towards my asymptote, so kind of make that look better. Because I have this y equals 0, that x-axis is an asymptote. Then from here, I have to get to this 0, and I know I don't dip below or come above. I also know this came from a multiplicity of 1, so it's going to go through like a straight line and come down. From here, I have to hit this guy. X minus 1 is also of multiplicity 1. So it's going to go through like a straight line, which means now I'm coming towards this asymptote. I'm going to be going down to the bottom. This asymptote came from here, which is of odd multiplicity, which means I'm going to split. One's going to be positive infinity, the other side's negative infinity. So here we're on the negative side. Here we're going to be on the positive side. Coming up, I'm going to come down towards the 0. This 0 is of multiplicity 2, so it is going to behave like an x squared. So that means it's going to turn and come back up and go towards the infinity again because I don't have any more zeros. This one is from here, which is of multiplicity 2, so it's going to behave like staying the same. So either both positive or both negative. So I'm going to be coming back here, and I know I'm going to come down on this 0. And if I wanted to be more detailed, of course, we could put in a ton more dots. So put in a lot more test points into all of these areas. I'm just trying to save a little bit of time on these videos because it doesn't take a lot of thought to put in another point or so. So I could have substituted 4 in here, 5 in here. I could have put in 1/2. I could have put -1 in. I could have put 2.5 into that function and cranked out those y values. So in practice, yes, you should be putting in more details. But I also wanted to make sure you understand the multiplicity, how that affects our asymptotes and so forth. I'm going to stop on this one. I have one more video for 3.6, which is going to talk about slant asymptotes.